Hi everybody, and welcome to our flipped lesson about angles in polygons. A polygon is a closed figure that has at least three sides, and the angles on the inside of a polygon are called interior angles. An angle that's formed by one side of the polygon and the extension of an adjacent side is an exterior angle. So we've got some pictures of that over here. Here's an interior angle, and then by extending one of the sides of this pentagon here, we're forming an exterior angle. So if you would notice, the exterior angle I'm pointing to and the interior angle that I'm now pointing to form a linear pair, so they should add up to be 180 degrees. And a regular polygon is a polygon where all the sides and angles are congruent. So I want to kind of quiz you and see if you remember the name for a bunch of our regular polygons. So here we've got a list. Obviously, if something only has one side or two sides, it's not going to form a polygon, but like a three-sided figure is a triangle. Pause the video and see if you can name the polygons with 4, 5, 6, 7, 8, 9, 10, and 12 sides. And once you're finished, unpause to check your work. Alrighty, cool. So hopefully you've got all these blanks filled in. First of all, we call something that has n sides an n-gon. Kind of weird. 4 sides would be a quadrilateral, 5 sides is a pentagon, 6 sides a hexagon, 7 sides a heptagon, 8 sides octagon, 9 sides nonagon, 10 sides decagon, and finally 12 sides a dodecagon. How'd you do? 100%? Yay! So a lot of what we're looking at today is going to involve formulas, but the first one of these formulas I want us to actually discover by doing this little activity here. So what we're going to do is we're going to divide each of the polygons here into triangles. The first one is already a triangle, but for example, if we were to start with the second figure, this quadrilateral, we're going to pick one vertex and draw lines out to every other vertex. Notice we're not drawing center angles, we're drawing we're drawing lines that start at one of the vertices. So this first shape, if I were to draw a line from the chosen vertex to the other vertices, I've got this line, which is just a side of the polygon, this line, which is just a side of the polygon, and the one that goes across. So what we're noticing is the quadrilateral could be divided into has 4 sides, but it could be divided up into 2 triangles. Pentagon, if I were to pick this vertex, I could divide it up into 1, 2, 3 triangles. So pentagon has 5 sides, whoa, and I've made 3 triangles. So again, pause the video, divide the other 2 shapes, the hexagon and the octagon, up into triangles, and in a minute we're going to see what pattern we notice. So hopefully your chart looks a little bit like this, and one pattern that you might be noticing is that if you look at the number of sides that each of the shapes has, we'll call that n, and then compare that to the number of triangles that you can make. The number of triangles, so over here in this column, is 2 less than the number of sides that each shape had. So like for instance, the hexagon had 6 sides, but you could only make 4 triangles. So if the number of sides is n, the number of triangles is n minus 2. And when we think about the sum of the interior angles, a triangle, we know, if we were to add up, I've got these 3 x's marking the interior angles. The sum of the interior angles of a triangle is 180 degrees. But then if I go and look at the quadrilateral, I've got 1, 2, 3, there's 180 degrees, and 1, 2, 3. There's another 180 degrees. So I've got 2 times 180, or 180 degrees, for each of the triangles that are there. So to think about the sum of the interior angles, I've got 180 degrees in a triangle, 2 times 180, or 360 degrees, is the interior angles of a quad. When I think about the pentagon, there's 1, 2, 3 triangles. Each one has 180 degrees. So 540 would be all my interior angles. 720 for the interior angles of a hexagon, and 1080 the interior angles of an octagon. Again, interior angles would be all these inside guys that I'm marking with X's. To generalize, so if we had a polygon that had n sides, we know that it's going to have n minus 2 triangles, and each triangle has 180 degrees in it. So n minus 2 times 180 is the general formula for finding the sum of all the interior angles of a polygon. And if you flip over to the next page, we're just going to jot down some formulas so that way when we come into class we're going to get a lot of practice using them. These are all related to the little exploration that we did on the previous page. You should try to do the example problems that go along with each formula, and that way you know which ones you still have questions on or the ones that are still confusing when you come into class. So, from the previous page, if we wanted to find the sum of the interior angles of a polygon, then we're going to end up doing n minus 2 times 180, where n is the number of sides that the figure has. So if you wanted to figure out the sum of the interior angles of a dodecagon, we're going to use that formula for n equals 12. The next one's probably everybody's favorite formula because it's not really a formula, it's just a number. The sum of the exterior angles of any polygon is going to end up being 360 degrees. Next one, if we want to find just one interior angle of a regular polygon, we just start with formula number 1. So n minus 2 times 180 tells me all of the interior angles of a polygon, but if I want just one of them, then I'm going to need to divide by the number of sides that I had. Same thing goes for one exterior angle of a regular polygon. We know from formula number 2 that 360 is all of the angles added up, but if I want just one of them, I'm going to need to divide by the number of angles that I have. Last two, if I'm asked to find the number of sides of a regular polygon and I'm given an exterior angle, then referencing back to formula number 4 for exterior angles, doing 360 divided by n is going to tell me what one of the exterior angles should be. So I'm just going to end up plugging in the information that I know. So if I'm given an exterior angle, I'll know what x is. Let's pretend that the exterior angle is 120 degrees. Then if I need to find the number of sides, I'm going to end up cross-multiplying and solving for n. Same thing for part 6. Find the number of sides of a regular polygon if I'm given an interior angle. So one interior angle of a polygon, I'm going to have to do n minus 2 times 180 to figure out what that sum of the interior angles is. Divide by n to find just one of them. And here I'm going to know the measure of the interior angle. So I'm going to plug that in for x and solve for n. Again, we're going to get practice using these formulas when we come into class. So the important thing to do now is really just to have them written down and to be ready to ask some questions. See you all in class.